Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to do question 14 and welcome to episode 14 of the product rule series on trigonometric functions. So for today we have the question f of x equals secant x multiplied by cotangent x, and we're asked to find the derivative of the function secant x multiplied by cotangent x. So the first thing you have to do is to first of all observe the question. As you can see, we have two subfunctions, secant x being the first subfunction and the second subfunction being cotangent x, and these two subfunctions are multiplied by each other. So therefore we have to apply what is called the product rule, and the product rule is basically the differentiation of functions that involve two subfunctions multiplied by each other, right? So now we have the derivative of the first subfunction, right, multiplied by the second subfunction plus the derivative of the second subfunction multiplied by the first subfunction. So therefore, the first thing you have to do is for you to identify what the first subfunction is. The first subfunction in this case, f of x, is equal to secant x, okay? And then the second subfunction is g of x, which is equals to cotangent x. And in order for you to be sure that what I'm saying is right, you have to compare. So you compare f of x, as you can see the arrow is showing you up top, and then g of x right here. Now, one thing you need to know, because it's product rule, you can interchange the positions, where secant x multiplied by cotangent x is the same thing as cotangent x multiplied by secant x. Just like 5 times 2 is the same thing as 2 times 5. The truth is you're going to get answer 10 here and you're going to get answer 10 here. So my point is, even if we had cotangent x multiplied by secant x and we applied the product rule to that, the answer we're going to get for this differentiation and for the actual question we have, secant x multiplied by cotangent x, is going to be the same. But for the purpose of calculus, we're going to be very careful the position that we put it in. So I just wanted you guys to know that's the reason why I'm making f of x, because I'm trying to be consistent with what the general formula and the product rule formula shows. So now that that's done, let us start applying the product rule to the question. So we have the derivative of secant x, right, multiplied by cotangent x, and what we have is the derivative of the first subfunction, in this case secant x, right, multiplied by the second subfunction, which is cotangent x, right, plus the derivative of the second subfunction, which is cotangent x, multiplied by the first subfunction, which is just secant x. What do we do now? Now, if you're new to my channel and this is your first video, you probably do not know this, but students who've been watching me for the past 13 videos, now the 14th, will be like, dang, she's about to talk about it again. Yes, I am. So on the next page, you would, the next thing you have to do is for you to look at your trig notes. So every single video that I put on YouTube or anything I teach, I always tell them to have notes concerning what you're learning. So in this particular question, we're dealing with trigonometric functions, right? It only makes sense for you to have a sheet of paper or a page in your notebook dedicated to trig notes. On the left side of this trig note, where everything is written in blue, you have trig expression. Trig expressions just involve how one trigonometric function relates to another trigonometric function. For example, how sin x relates to cosecant x, right? Or how cosine x relates to secant x. Or how tangent relates to sine x and cosine x. Or how cotangent x relates to cosine x and sine x. So that's what we see in trig expression. The right side of the page up top, what we have written in blue is trigonometric identities. These show up whenever our trig information actually has squares, right? So they are called trig identities. And all of this information, if this is for your first video, make sure you pause this and just write all of this down. Have a section for trig expression, a section for trig identities, as well as the last one that we're doing, which is everything written in red. This is called trig derivatives. If you don't know this information, I would advise you to write it down and to master it, because if you're in one of those classes where you're not allowed to use a cheat sheet or a paper to help you with a whole bunch of formulas, I would advise you to do so many problems. And if this is your first video, go watch the first 13 video and the last video of the series, which is going to be the 15th video, which is the video after this one, and just go learn from it. That's the best I can advise you to do. So now that we have all of this information down, we're asked to find the derivative of secant x. Well, looking here, we can see that the derivative of secant x is the same thing as secant x tan x. So we can just come here. The derivative of secant x is secant x tan x multiplied by cotangent x plus, what is the derivative of cotangent x? Well, the derivative of cotangent x, then go back to our trig notes. Derivative of cotangent is, it's at the bottom here, at the bottom left, which is negative cosecant square x. So we're going to put negative cosecant square x, right? That's that multiplied by our gorgeous friend here called secant x. So we rewrite this and you have secant x tan x cotangent x, right, minus secant x cosecant squared of x. So that's basically it. Now the first thing that you should do is, even though actually this is the last part of the information if you want to just leave it this way, you already found it, you already derived it, you already added up both sides of the derivative, and you had this. So this answer is alright, and this is actually the answer to the derivative. But the thing now is, since we're dealing with trig, just like everything else in math, whenever you have a complicated information, you're advised to simplify. So even though this is correct, we're dealing with trig and we can simplify further. We already have the trig notes that teaches us the different ways for us to represent trig information. So we're going to use that as a guide. So I'm going to rewrite this stuff at the bottom, and then we're going to simplify, right? So we have secant x tan x cotangent x minus cosecant squared x secant x. So the first thing we do is, when we want to simplify, because we have secant on the left side here and on the right side, let's first of all bring out secant and see if bringing it out is going to make our work easier. Hopefully it does. Actually, usually it does when you bring stuff out. So secant x, you bring that out, so you have tan x cotangent x minus cosecant squared x. So this is what we have. Now, the way I like to do my work whenever I'm trying to simplify stuff is for me to change our trigonometric function in terms of sine and cosine. And that's what we're going to do here, right? We're going to represent it in front of sine and cosine. So what I'm going to do is, what is the trigonometric expression that represents what secant x is? Well, secant x is the same thing as 1 over cosine. So I'm going to put that here. So 1 over cosine of x, right? What is tan x in terms of sine and cosine, since that's what we're representing? In terms of sine and cosine, tan x is the same thing as sine x over cosine x. So we're going to say sine x over cosine of x. And then what is cotangent x? Cotangent x can be represented as 1 over tan x, which is the same thing as cosine x over sine x. So we're going to say multiplied by cosine x over sine x. Okay, then, we're not going to do the big bracket yet. So we have that minus cosecant square x. What did we know cosecant square x to be? Well, cosecant square x is actually the same thing as 1 over sine square x. But in this case, we just have cosecant x and 1 over sine x. Well, when you have cosecant square x, right, is the same thing as cosecant x multiplied by cosecant x, and is the same thing as 1 over sine x multiplied by 1 over sine x. So therefore we can call this 1 over sine square x. So therefore cosecant square x is the same thing as 1 over sine square x. I just wanted to do that little information because I don't want people to be confused and be like, where did she get that? That was not what was in the trig notes. But that's just simple math. And if you don't understand what I just did, just rewind it and listen to it again. So you have 1 over minus 1 over sine squared of x, right? Since that was what we have, guess what? We wanted to simplify, right? Well, we have cosine divided by cosine and sine divided by sine. You can see how excited we are. Ah, thank God. So 1 over cosine of x is the same thing as 1 minus 1 over sine squared x. And yeah, that is the answer. So you see how this answer was alright, right? Which is just a rewrite of what we had here. This answer was alright. This answer is also alright. But we're also dealing with something that you can simply call trig. So let's turn it back into something that we know. So let's make it look like it's not sine and cosine. So 1 over cosine, we know that to be secant x, right? Over 1 minus, what is sine square x? Sine square x is the same thing as cosecant square x. We just did that like 30 seconds ago. So this is, you can represent our answer this way or this way, right? But then we're also dealing with trig, right? So what is secant x again? Sorry, what is we're also dealing with trig. So this is, our work is actually not done. Even though the answer is correct, there's more that can be done with it. So we have secant x multiplied by 1 over cosecant squared of x. Now, we have something, we cannot like simplify this further in terms of factoring and cancelling stuff out, but we can simplify this further by means of something called substitution, right? So when we look at 1 minus cosecant square x, what in the trig note represent something that has squares, represent trigonometric function that has squares. Then we go look at the trig identities. And from the trig identities, we have cosecant square x, cotangent k. We have all of these 3 trig identities, 1, 2, 3. But the one that is very similar to what we are trying to apply is the second one. So I'm going to go to this page and write, remember, cotangent square x plus 1 is equals to cosecant square x. So therefore, if I bring cosecant square x this way, so if I say 1 minus, if I say cotangent square x plus 1 minus cosecant square x equals 0, I can also say 1 minus cosecant squared x, right, equals negative cotangent square of x. So we can substitute this and make our work neater. So we end up with secant x multiplied by negative cotangent squared of x. Now, even though this answer is also okay, like just like the previous one, still the same exact answer, just represented differently because of different trigonometric functions. Well, we know that secant x, let's see if we can simplify this further. We know secant x is the same thing as 1 over cosine of x, right? Multiplied by what is negative cotangent square x. Negative cotangent square x Well, what is negative cotangent? We see that cotangent, when we want to represent in terms of sine and cosine, is the same thing as cosine over sine. But then we have cotangent square x. That's going to be cosine square x then over sine squared of x. So what do we end up with? So we cancel this out. We cancel this out. So what we end up with is cosine x over sine squared x. And we can represent this as cosine x, right, over sine x multiplied by 1 over sine x. And then when we go further to understanding what we're doing, we remember now that what is cosine x over sine x? Let's go back to the trig notes. Cosine x over sine x is the same thing as cotangent x. So we put that down here. Our answer to be cotangent x. Okay. What is 1 over sine x again? 1 over sine x is cosecant x. So we put that here. Sorry. So we put that here. Cosecant, not cosine. CSC x. Cosecant x. Now, if you look at our work, we can see that I mistakenly left something out. So we have negative cotangent square x. We put the negative here, the negative here, the negative here. So we end up with negative cotangent x multiplied by cosecant x. So therefore, the derivative of what we actually were supposed to derive in the first place, secant x multiplied by cotangent x, is this answer right here. Now, this answer here is correct. 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 But the best answer that I would say, that I would pick, that is the most well broken down and the least complicated, is negative cotangent x cosecant x, because you know how like tiring it's gonna be for you to remember or for you to learn the derivative of secant x cotangent x, and you say secant x tan x cotangent x minus cosecant square x secant x. It's already complicated enough. That's why we have trig to simplify. That's why we have the trig note to help us in to further simplify our work, right? Just like if we have like 50 over 100, you can just say 1/2. You know, that's basically what we did, but in trig form. So now this is good info straight up, but what if you don't have time and you have to do a shortcut method? Well, if you've been watching my previous videos, you already know what the shortcut method is. This is whenever you're given a function, and before differentiating it, you're going to represent and simplify that function, and then differentiate or derive the simplified version of the function. So you have secant x cotangent x as f of x, right? And you're asked to find the derivative of secant x, which is our question, right, from the beginning, cotangent x. Well, what we can do is to first of all simplify what is in here. So we have secant x cotangent x, right? We can write this as 1 over cosine x when we look at the trig notes. I hope you have your trig notes. And then cotangent x is the same thing as cosine x, right, over sine x, right? Now we have that. We can just easily cancel this out, and the next thing you end up with is 1 over sine of x, right? So that is what you now have as your broken down answer. Now we take the derivative of the broken down or simplified information. So we can take the derivative instead of taking the derivative of secant x cotangent x. Instead we take the derivative of 1 over sine x, which is the same thing as taking derivative of what? 1 over sine x, what did we say it was again? In that method, 1 over sine x is cosecant x. So instead, we take the derivative of cosecant x. And when you look at what the derivative of cosecant x is, let's go to the trig notes. We can see that the derivative of cosecant x is this gorgeous one here. Negative cosecant x cotangent x. That is our answer. So we can put this there, here, to be negative cosecant x cotangent x. You can see how beautiful this looks. So gorgeous. This shortcut method was only done in one page. Now, if you're in an exam or you have an assignment and you want to confirm your answer is correct, or you're in an exam and you're supposed to do multiple choice question, if you've practiced so much of calculus, then you know that you can just easily just do the shortcut method and get the right answer. So instead of doing all of this that we did from here to here to here, you'd have just done all of this in one page and still gotten the right answer. So I hope this video was very helpful to you guys. This is the 14th video of this episode. We have one more episode and we're going to be done with this series, and it's going to be the 15th question, where we have cosecant x cotangent x. Highly interesting. I wish you guys make sure you guys go on to watch it or attempt the question and then watch it to see if you got the right answer. And you can put that in the comment section if you did. Make sure you guys have a good time, and I wish you guys all the very best. If you have any questions, please look into the description box to see if your questions have already been answered over there, and if it hasn't, please leave a comment in the comment section. And I wish you guys a very good day and a great grade in your course. And Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.